So then we'll start on the first question in part A now. So this image shows that we have 14 towers, and the height of the tower is measured from bottom of its base to the highest point, including if like poles or antennas. So pretty easy things there. And it asks if the towers are listed from shortest to tallest, what is the 10th in the list? So basically, what's the 10th tallest building? Now, instead of counting from shortest to tallest, like your first instinct might be, instead, what we can do here is actually count from the back. So we first look at the tallest towers and count backwards. So since there's 14 towers, we want the 14, 13, 12, 11, 10th. So the fifth tallest tower. So I'll just write that down. Now we can see obviously this tower here is the tallest. And then looking at the lines, I believe this one is the second tallest. This is the third tallest. Um, fourth tallest one here. And yeah, this is the fifth tallest. So therefore, the answer is just A here. Now, you can see in this example, we used like a method called backwards counting. So, working our way from the back. You could work your way from the front and count from the shortest to tallest, but that's just much more work then. That's like almost twice the amount of work. So this is a better strategy, in my opinion, here. Crypto keys. So it says Jan uses a special keyboard for writing secret messages. When a key on a keyboard is pressed, a different letter is displayed on the screen according to the following map. Basically, it gives us an example. When Jan presses the S key, the letter E is displayed. That's because there's an arrow from S to E here, you can see. Um, and vice versa, when E is pressed, S is displayed. And it says Jan types the letters QOEU. And what was the original message type? That's what it's asking. So first Q, we look at the letter Q. Q is here. And in order for Q to appear on the screen, we can see that since there's an arrow connecting it with W, that means Jan must have typed W first. I'll just write the four letters spaces here. Okay, and then the second letter was O. We look at O here, and since it's corresponding to I, that means the second letter must be I. Similarly, E, E is here, and it already gave us this in an example. Great, so she must have typed S. And finally, U. If you look at U, and it corresponds with H, so that must be the final letter. And look at the answer choices, we see that wish, it's choice D. Yeah, simple as that. Cookies. Four children ask for cookies. Adam says, I don't want any stripes. Bella says, I don't want a cookie to be a I want my cookie to be a circle or square. Kai says, I want a cookie with round dots, and Diego says, I want a star shaped. And then it's asking for which assignment will fit all the children's requests. So here we just work our way looking at the statements. So first of all, Adam says he doesn't want any stripes. Looking at the answer choices, A, in, in answer A, Adam has stripes on his cookies, but he doesn't want stripes. So therefore, we can first just rule out answer A. In B, C, and D, none of them have stripes, so then we move on to the next statement. It says, Bella says, I want my cookie to be a circle or a square. Looking at the answer choices, we see choice B doesn't satisfy that because this is a triangle, which is not good. So therefore, we can rule out answer B. And then we move on to the third statement. Kai wants a cookie with little round dots. In choices C and D, we can see they both have circular dots. So this statement therefore doesn't really tell us anything more. But then finally, if we look at the last statement, Diego wants a star-shaped cookie. And out of these two shapes of cookies, we see clearly D is a circle, not a star. So we can rule D out, and the answer is thus C. So we can see here we use the method called ruling out answer choices or eliminating answer choices. This is a very helpful method, not only for Beaver, but for many other contests in the future you can take. This is an interesting question. Zhi likes to draw. He creates his pictures by drawing dots and then connecting them with line segments in one motion. Remember, one motion, and never picks it up. Never picking up his pencil and never drawing on the same line segment twice. So these are some very important conditions here. And the following gives us an example of a drawing of a house that satisfies how it's in one motion, he never picks it up, and he never draws the same line segment twice. And then now it's asking which of the following pictures can Zhi draw? So one way of tackling this problem is to just experiment. But there's actually a very special concept here. So whether or not it's possible to draw a shape without lifting your pencil or without drawing the same line segment twice, it actually depends on the number of points with an odd degree. So what do I mean by this? Say we have a point with three lines coming out of it. So in this case, the degree would be 3. So the degree is essentially the number of lines that stem from that point. Now, how does this work? Well, so I'll make a chart actually. Um, Whether it's possible and number of points with odd degree. If the number of points with odd degree is bigger than 2, it's actually no, it's impossible. If the number of points with odd degree is 2 or 0, yes, it is possible. Why is this? For example, let's look at choice A. This point has only one line coming out of it, and therefore it is a degree of 1, which is odd. Similarly, these 2 points also have degree of 1. Bear with me for a sec. Let's look at this line here. If we ever go on this line, we either have to go from like this, which actually just ends our entire drawing because once we're at this point, there's no other place we can go. Or we go from it like this way and we end up on this point here. But in order for us to start this way, we can only start on this point here. And therefore, this must be the point we start at. Now, by a similar logic, if we look at this point, we either travel this way or this way, but in either instance, it must be the start or finish. In other words, for this point, and this point, we must start or finish there. However, there's 3 points that are the start or finish, but there can only be 2 points that can be a start or finish. There's either one start and one finish, but we have 3 points. Therefore, this doesn't work because we can't have 2 points being the start, right? That's impossible. We can't have like this point and this point being the start. So therefore, A is wrong, and that's basically the essential idea behind this chart here. So now we can simply look at which chart has 2 or 0 points with odd degrees. So for chart B, we can see this point has a degree of 1, has this point has 1 line stemming out of it. This one has 3. This one has 3 as well. But then immediately, that's already 4 points that have an odd number of lines coming out of it. That's bigger than 2, right? So therefore, B is wrong as well. And with C, 2, I'm just drawing the number of lines that come out of the point. 1, 2, 3, and 1, 2, 3. So choice C is actually perfect. There's exactly 2 points that have 3 lines coming out of it, or an odd degree. And therefore C is the right answer here. And for D, by simple observation, we see that the triangle and the square are completely disjoint. They're completely separate objects, and therefore there's no way we can draw the two objects without lifting our pen up. So therefore the answer is C. Now let's move on to the final question from part A. A map of 5 towns. The towns are black dots, and 4 highways or colored lines is shown. To represent this map using a diagram, there is one labeled circle per town, and the following is true for every 2 towns. It gives us 2 statements here. If you can drive from one town to the other using exactly one of the 4 highways, then a straight line joins the circles. And if you cannot drive from one town to the other using exactly one of the 4 highways, then no straight line joins the circles. And then it's asking which diagram best represents this map. So let's just see. Let's just start on point T and observe some things. There's a line joining T and S, as well as the highway or the green line joining T and R. So by the first statement here, we can drive from point T to point R using the green highway. So therefore, there is a straight line that joins their circles. Looking at the answer choices, A, yeah, A has a line that goes from T to R, right? But notice how in all the other answer choices, like choice B, there's no line connecting T and R, which it should have. Similarly, C, there's no line here, and D, there's no line connecting T and R. So by this one observation alone, we just eliminated yeah all the 3 answer choices and got the answer. So again, an example of like eliminating answers, a tactic we can use. And I believe that concludes part A.